Yeah, good afternoon. Today we are going to discuss about the types of buses. It is based on the DT based delivery. So here we will discuss about what is bus and how the buses is classified, and what are the known parameters, known quantity and unknown quantity will be there. It is based on the buses. So we will see based on the role play.
I am a generating station. I am producing electricity. Now I connected with bus.
I am bus. I am connected with many intercomponents connections with generation and load and transmission lines, and made up of aluminum and copper. And the transformer one, I will going to supply electricity for from North region.
And the transformer 2, I am going to power up the southern part of the country. And transformer 3, I am connected in Suru DC.
Okay. So here, this is called a bus. The bus is made up of either copper or it may be an aluminium. The bus, it contains zero resistance, or it may be called as negligible resistance. So here the bus does not contain any resistance, so there is no voltage drop. If the voltage drop is there, not there, means the voltage is always same. The voltage is always remain constant. So that is called bus. It is just like a copper bar or aluminium bar, just like pipe. Okay. So here the bus is called the connection of or the meeting of various element or various equipment is called bus. For example, in this bus, it contains various element or equipment, like it may be contain a number of generator and a number of transformer which are connected with the one system. This is called CAN bus. So for example, here one generating station will be there. So from the generating station they are producing the electricity. The produced electricity will be supplied to the bus. The produced electricity, it will be supplied to the bus, and it contains a number of transformer, a number of outlet. So one is for Coimbatore North region, another one is for Coimbatore South region, and another one is for Sulu region. So like that we can divide into a number of outlets. Okay. So here all the three transformer and all the generator, it will be connected with the bus bar. So generator is the incoming, and remaining all the transformer, they are distributing the electrical energy to the various regions. Okay, but all the equipment which are connected with bus, because the bus is the meeting point. That's why it is named as bus, and here the voltage is always same. Okay. So on the electrical parameter, so there are four parameters will be there. One is real power, reactive power, and magnitude of voltage, and the phase angle. So based on the four parameter, we are dividing the buses. By using the four parameter, we are dividing the buses like a generator bus, or it may be called as PV bus, and second one is load bus, or it may be called as PQ bus, and third one is slack bus, or it may be called as swing bus, or it may be called as reference bus. So based on these parameter, we can classify the three buses. So in each bus, there are out of four quantity, only two quantities are known, and remaining two quantity, it is an unknown value. So we have to determine by using either Gauss-Seidel or Newton reduction method. These are some of the iterative method. So we will see how the buses can be classified.
The generator bus, filled with the air power, filled with the voltage of magnitude. From now, I want to determine the reactive power and the phase angle.
So this is called a generator bus, or it may be called as PV bus. Why it is called PV bus means, so in the generator bus, we know the value of real power and as well as the magnitude of voltage. So the real power, which is indicated as P, and the voltage is indicated as V. So here P and here V. So the combination of P and V is nothing but PV bus. So the generator bus is also called as PV bus. Here we know the value of only the real power and the voltage. So we don't know the value of the reactive power which is supplied by the generator as well as the phase angle of voltage. So we have to determine the phase angle as well as reactive power by using any Gauss-Seidel or Newton reduction method. So this is a first bus. It is called a generator bus, or it may be called as a PV bus.
From here, I am the load bus. I know the value of real power and reactive power, and the rotation of real power is P, and the rotation of the reactive power is Q, and I also known as the PQ bus. I want to determine the magnitude of voltage and the phase angle.
So the second bus is nothing but a load bus. So you can draw on the electricity from the bus. So in the PQ bus, it is denoted as PQ bus because you know the value of P. P is nothing but an real power and Q is nothing but an reactive power. So based on the known value of real power and reactive power, it is called a PQ bus. But here we don't know the value of, so what is the bus voltage and what is the phase angle of the voltage. So we have to determine the voltage as well as the phase angle of voltage. So both we have to determine. So that is nothing but a load bus, or it may be called a PQ bus.
I am slack bus. I am also known as a swing bus or reference bus. I am very specified in magnitude of voltage and magnitude of phase angle. I want to determine the real power and reactive power.
So here, so based on the four quantity like the real power, reactive power, voltage and the phase angle. So based on this, for each bus the two quantity will be known, another two quantity will be unknown. So based on that, it will be a generator bus or PV. Only two quantity will know unknown, and for load bus only two quantity will be known. That is, one is for P, another is for Q. But the third one, slack bus, is nothing but it is also a generator bus. The slack bus is also called generator bus, or it may be called as swing bus, or it may be called as reference bus, because and power system, it contains n number of generator. It contains n number of generator. That is nothing but NPV bus. It may be 2, 3, 4, 5, 6, and etc. But out of all the generators, any one generator will be act as a swing bus or slack bus. That is called a reference bus. Okay. So in this reference bus, instead of the P and V, instead of real power and voltage, for the slack bus, we know the value of the voltage which is supplied to the bus, and as well as, so what is the phase angle of the voltage. So only these two parameters, these two quantity will be known, and we don't know how much amount of real power and reactive power which is generated from the generator and which is supplied to the load through various buses. So here, by using the Gauss-Seidel or Newton reduction method, here we have to determine the real power and reactive power which is consumed by the various loads as well as in all the buses. So that is called a slack bus. So based on the four quantity, we can able to classify the types of buses. One is called a generator bus, or it may be called as PV bus, and second one load bus, or it may be called as PQ bus, and third one is also a generator bus, but which is called as slack bus, swing bus, or it may be reference bus. So based on the reference only, we are proceeding the further calculation to determine the unknown quantity of either real power, reactive power, voltage, or phase angle. So this can be done with the help of an iterative methods. So if we can able to get the unknown value in the one iteration, or maybe second iteration, or maybe third iteration. So we have to go up to the nth iteration to determine the exact value. So it should be within a permissible limit. So these are the various types of buses. Any doubts?